Hello viewers, welcome to Learn Computer Easy channel. This video is about binary codes. Binary code means it is used to, these are the codes used to represent the data which are feed into the computer. We feed many data into the computer to store or process or anything. The data may be a number, an alphabet or a special character. These data are represented in a computer in the binary form. Those binary forms are called binary codes. So this video is about binary codes for decimal numbers. We have binary codes for alphabets also, special characters, and we have also error detection codes for data which we given when the data is transferred from one computer to other computer. The error detection data code is used for the data which are transferred from one computer to another computer. For those data also we have binary codes. Okay, this video is purely about for binary codes for decimal numbers. We have 4 binary codes for decimal numbers. First one is binary coded decimal, otherwise called BCD or 8421. The next one is excess 3 code, and next one is 84 minus 2 minus 1 and 2421. Binary code BCD or binary coded decimal and 84 minus 2 minus 1, 2421 all are weighted codes. Why? Because for each digit in the binary code we have some weightage, that is the numbers 84 minus 2 minus 1, 8421 and 2421 are all weights for binary codes. First we will see binary coded decimal, that is BCD. Binary coded decimal is a 4-digit number. It is similar to binary conversion from number 0 to 9. The binary coded decimal has 4 digits. Why? Because the number 9 and 8 is represented by 4 digits. That's why we have binary coded decimal in 4 digits. Okay. BCD is otherwise called 8421. This is also called weighted code, and it is also called self-complementary code. Why? Because if we convert the ones and ones into zeros and zeros into 1 in the binary code, that is BCD code, it will be similar to the 9's complement, that is binary form of 9's complement of the particular decimal number. Okay, we will take numbers from 0 to 9. For 0 we have 8421. How we get BCD code for decimal number means we have to choose numbers among those 8421, these 4 numbers, so that the number we choose whose sum of the digits will be equal to the decimal number which we taken. For example 0. For 0, if we put any ones here for 8421, we can't get 0. So we will put 0. 4 zeros. The next one is 1. For 1, we should choose the number from 8421 which is equal to 1. Here we have 1. So directly we can put 1 to the 1. For other digits 0. For 2 we have 2 itself. So we should put 0 1 to 2. We should assign 1 to 2. For other digits we should assign zeros. For 3 we don't have 3 here. So we should choose the numbers from 8421 so that whose sum of the digit should be equal to 3. For example, here 2 plus 1 3. So we should put that is we should assign 1 for 2 and 1, for others 0. Okay, for 4 is already there, so we can put 1 for 4, for others 0. The next is 5. 5 means 4 plus 1 5. So for 1 and 4 1, for other numbers 0. For 6, 4 plus 2 6. So for 4 and 2 we should assign 1, for others 0. For 7, 4 plus 2 6, 6 plus 1 7. 0. For 4 1, 2 1, 1 1. For 8, 8 is already there, so we can assign 1 directly for 8, for other numbers 0. For 9, 8 plus 1 9. So we should assign 1 for 8 and 1, for remaining numbers 0. Likewise, we should arrive BCD code for decimal numbers. This code is similar to binary conversion from 0 to 9. From 10 onwards it will be different for BCD. Why? Because here for 9, from 0 to 9 we directly assign the digits. From 10 onwards we should separate 10 as 1 and 0. For 1 we will get separate code, and for 0 for separate code. For example, 43. 43 is represented as 0 1 0 0 for 4, for 3 0 0 1 1. Okay, this is not similar to binary conversion. For binary conversion we will continuously divide the 43 by 2 and we will get a remainder. We arrive those remainder as the binary conversion for 43. For BCD code we directly separate the 43 as 4 and 3. We write 4 for binary representation for 4 and separate representation for 3. This is the difference between BCD and binary conversion. The next is excess 3 code. Excess 3 code, we can get excess 3 code by adding 3 to the decimal number, and the answer is represented in binary form in 4 digits. For 3 we should add 3 to 0. 3 plus 0 3. So we should write the excess 3 code for 0 as 0 0 1 1. This is binary conversion of 3. Okay, for 1 plus 3 4, 1 plus 3 4. So we should write excess 3 code for 1 as 0 1 0 0. This is the binary form for 4. Next 2 is 2 plus 3 6. The excess 3 code for 3 is 5. 2 plus 3 5. Excess 3 code for 2 is 5. 5 is represented in binary form as 0 1 0 1. For 3 plus 3 6, 0 1 1 0. For 4 plus 3 7, 0 1 1 1. This is the binary form for 7. This is the excess 3 code for 4. 5 plus 3 8. 8 is represented as 1 0 0 0. For 6 plus 3 9. 9 is represented as 1 0 0 1. For 7 plus 3 10. Excess 3 code for 7 is 10. 10 is represented as 1 0 1 0. For 8 plus 3 11. So excess 3 code for 8 is 11. 11 is represented as 1011. For 9, the excess 3 code is 12. 9 plus 3, 12. 12 is represented as 1100. This is the excess 3 code for the numbers from 0 to 9. Next we will see 84 minus 2 minus 1. Eight 4 minus 2 minus 1. This is similar to BCD code. BCD code we have 8421. Here 84 minus 2 minus 1. The number is different. The method is the same as BCD. Okay. For 0, we don't have 0 here. So we should assign 0 for all the numbers. Okay. For 1, we should choose the numbers from 84 minus 2 minus 1 so that whose sum of the digit should be equal to 1. Okay. Here 4 minus 2, 2, 2 minus 1, 1. So for 4 minus 2 minus 1, we should assign 1. For 8, we should assign 0. 4 minus 2, 2, 2 minus 1, 1. We get 1. So we should assign 4 minus 2 minus 1 as 1. Next is 2. 4 minus 2, 2. So we should assign 4 and minus 2 as 1. For 8 and minus 1, 0. Next is 3. 4 minus 1, 3. So for 4, 1. Minus 2, 0. Minus 1, 1. 4 minus 1, 3. For 4, 4 is already there. So we should assign 4. We should assign 1 for 4. For others, 0. Next is 5. 8 minus 2, 6. 6 minus 1, 5. That is 8 minus 2 minus 1. We add 8 minus 2 minus 1. 8 minus 2, 6. 6 minus 1, 5. So we get 6 by adding 8 plus minus 2 plus minus 1. So we should assign 1 for 8, minus 2, minus 1. For 4, 0. Next is 6. For 6, 8 minus 2, 6. So we should assign 1 for 8 and minus 2. We should assign 0 for 4 and 1. Next is 7. 8 minus 1, 7. So we should assign 8 and minus 1 as 1. For others, 0. Next is 8. We have 8 already there. So we should assign 1 for 8. For others, 0. Next is 9. For 9, 8 plus 4, 12. 12 minus 2, 1. 12 minus 2, 10. 10 minus 1, 9. So for 9, we should put all the 8, 4, minus 2, minus 1 as 1. That's all about 8, 4, minus 2, minus 1. 8, 4, minus 2, minus 1 is also a self-complementary code and weighted code. Next we will see 2, 4, 2, 1. Two, 4, 2, 1. We don't have 0 here. So we cannot assign 1 for any values. So we should assign 0 for all the numbers. Next one is 1. 1 is already there. So we should assign 1. For others, 0. For 2, we have 2. 2 is there. We can decide any one of the 2. I take this 2 as a answer. We should assign we should choose any one of the 2. I choose this 2, so I put 1 here. Next one is 3. 2 plus 1, 3. I choose these two, 2 plus 1 3, so I assign 1 for these 2 and 1, for the remaining 0. For 4 is already there, I assign 1 for 4, for others 0. Next one is 5, 4 plus 1 5, so for 4 and 1 I assign 1, for others 0. Next is 6, 4 plus 2 6, I assign this 2 and 4 as 1, for others 0. Next one is 7, 4 plus 2 6, 6 plus 1 7, for 4 these 2 and 1 I assign 1. Next is 8, 4 plus 2 6, 6 plus 2 8, so I assign 2 4 and 2 as 1. 4 plus 2 6, 6 plus 2 8, for 1 I assign 0. Next one is 9, 4 plus 2 6, 6 plus 2 2, 4 plus 2 6, 6 plus 2 8, 8 plus 1 9, I assign all the 4s as 9. Okay, that's all about 2421 code. These are all the binary codes for decimal numbers. In next video I will show the binary codes for alphabets and special characters, and we will see the error detection codes also. In this binary codes for decimal number, BCD 84 minus 2 minus 1 2421 are weighted code, and excess 3 code 84 minus 2 minus 1 and 2421, these are all self complementary code. Why? Because if we change the zeros into 1 into 0, we will get the 9's complement for the decimal number.